Okay, here's the topic. All right, and we want to chart how energy goes to and from, and where it goes and where it comes from. All right, so I want to look at this reaction, sodium bicarbonate and citric acid, and here's a video of it. And you'll notice it starts at uh, there was like a little bit below 20, and now I'm adding the sodium bicarbonate, and there it's fizzing up. And this is actually an acid-base reaction, so you'd think, hey, it's going to be exothermic, but when you look, you can definitely see that the temperature went down. So this is an endothermic process. Where did the energy come from? Where did it go? Which way was it going? Now, um, here's another reaction. This is acid and base. Again, these are concentrated, 3 molar, that's pretty concentrated. And it's also a different type. This is a really strong acid, and this is a strong base. And the last one with citric acid, it's a different type of reaction. It's a different reacting with a different type of base, a carbonate, not hydroxide. All right. So here, the energy began around 20 and ended around 38. This is clearly the energy. The thermometer went up. So what is this? This is an exothermic reaction. All right. Because in the endothermic, which was the citric acid and the sodium bicarbonate or baking soda, the energy, it went from there to there. All right, it went from the water of the solution into the reaction, which were the chemicals, and therefore the temp of the water went down. All right, and in the exo, it's the reverse. With the acid and base, KOH and HCl, they are my system, and they go into heating up the water. And it's really the hydronium and hydroxide that release into the water. All right, and therefore the temp goes up. And in lab, one thing in both of these and in lab, we're often going to measure our surroundings. Not you're really, and you're kind of measuring it all because the system's there too. And there are two ways that energy can go from my surroundings into my system. Two different types. You can do work on the system and the surroundings can compress the system, and that's a positive P delta V, pressure change in volume, and it also can heat it up. And the two ways for exothermic, for the system to do work on or to transfer energy to the surroundings, is the opposite, where it can expand the surroundings and it can also heat it. And this is an example of uh, your two different uh, ways of pressure and volume work, or PV work. You can see here the cylinder is being compressed by the surroundings. All right, and this is doing work on the system, and then boom, I have a ignition, and that expands the cylinder. So now the system is doing work on the surroundings. So this piece here to here, because the surroundings is compressing my system, that is endothermic, and this is exothermic. Here are my sources. Thanks for the image, and thank you, Miss Leggett, for your help. All right.